So here's the first problem. A fast train travels 2 miles in 1 minute 30 seconds. Now at this rate, okay, so this is the rate, that's the speed, okay? And how many miles will the train, okay? The train travel in 1 hour, okay? So let me travel in 1 hour. Now, so first of all, you are given the speed, okay, but maybe it's not in perfect form. Then which formula we're going to use? So first of all, you write down the formula, okay? And the formula says that the speed is going to be the distance divided by the time. So you're looking for the distance. So the distance is a speed times time, okay? So you have to figure out the speed. You have to figure out the time is given. Now, the speed, okay? You have to have the same units, okay? 2 miles, in 1 minute 30 seconds, okay? So you have to convert the 1 minute, okay, 30 seconds to an hour, okay? Or you can use either way, can convert, but it have to 1 minute 30 seconds. You have to use that as you can change it to the minute here first, right? So the speed is going to be 2 miles divided by 1. You can, if you use a minute, then divided by 1.5 minutes. Okay, right? So 1 minute equals 60 seconds, and it's a 1.5. Then you can keep it at this moment. Okay, then the time here, you should also use a minute. So it's 1 hour is going to be 60 minutes. Then after you multiply them out, you get the same answer. You get the answer you want, okay? So the distance equals the time, okay? Divided by, the time, the time, the speed times time. So it's time, okay? Then you do the simplification, and then how do you simplify it a little bit, right? So you can, you can use it. You can do it by hand. You do the multiplication. Also, 1.5. There's yeah. Okay, 1.5 is going to be 3/2 times 60. Okay, times 60, and okay. So then you can simply, turn this upside down is 2 times 2 divided by 3 times 60. Then you simplify it, right? It's going to be 80. Okay, yeah, so 80 miles per hour. Okay, and that is going to be 20, and then 20 times 2 times 3 is 80. Yeah, this is not fast train actually. Okay, forget it. This is not fast train. Okay, but anyway, this is a slow train. Okay, so 80 miles per hour. But okay, so then let's take a look at the second problem. Okay, so the only problem, this is the easy problem, right? The first problem, but make sure you have to use the same units. You don't need to convert the speed as miles per hour, miles per minute. That's enough, because use the other one, then you have to convert the 1 hour to minutes. Okay, so the second one, let's take a look at the second one. If you walk for 30 minutes at the rate of 4 miles per hour, and then run for 30 minutes at the rate of 1 mile per hour. Okay. Okay. No, it's not 1 mile per hour, 12 miles. Okay. Right. So what is the average speed? Okay, what is the average speed? Okay. So you have to record the definition, right? The average speed is given the distance, total distance you travel divided by the time. Right? So you have to figure out the distance and the time. But the time is given, right? The distance is not given. So you have to do calculation. Okay, right? So distance, right? So distance 4 miles per hour, first of all, right? And then 30 minutes, so it's 4 times. 30 minutes is just half of the mile, half of the 1 hour, right? And plus, at the rate of 12 miles per hour, also 30 minutes, so it's half hour, right? So that is the total distance it travels. So you can get 2 plus 6, which is 8. So the unit is 8 miles. Okay. Now you want to find the speed, right? The average speed. So you have to figure out, depends on time. You want to use minutes, but usually when we talk about speed, it's per hour, right? So then you have the 1/2 plus 1/2, it's 1 hour. Okay. Then the speed, then you can figure out speed is going to be 8 divided by 1, it's 8 miles per hour. Okay. Yes. Yeah, that's how they do it. Now I'm going to not do the third one. You can look at and do it by yourself. Okay. So if someone drove 125 miles in 1 hour and 40 minutes, what is the average speed in 1 hour in miles per hour? So this just needed to convert it to the same units. Okay. Correct? That's an easy problem. So I hope you can quickly figure it out. Yeah, we are going to also do some more challenging problems later. Let's review, let's practice first on those problems. Okay. Anyone has answers? Right, we're talking about average speed. So the speed, you write on the formula when you do the homework, speed is distance divided by time. Okay, so now you know the distance, it's 125 miles, right? 120 miles. So question is, what is the hour, right? So time is 1 hour, 40 minutes, so 40 divided by 60, right? So it's 1 plus 40 divided by 60 is 4/6. It's 2/3, then add them together, it's a 5/3 hours. Okay, then the speed is going to be 125 divided by 5/3, right? And that is going to be 125 times 3/5. Okay, 125 divided by 5, it's going to be 25. 25 times 3 is 75. Don't forget to put the unit in. So when you do the homework, if the answer does not match with what is given in the book, for example, and if you show all the details like that, this is what you have to learn, okay? We're not just only focused on the answers. We needed to learn how to express clearly. So you write all the formula you need, okay? And then try to figure out the quantity for each, the number, for each quantity. So you do the calculation, then you put them into the formula, then show the details. So if the answer is wrong, if you still can figure out why it's wrong, then you ask your parents to take a look. They know which step you make mistakes. Okay. Thank you for Mike. First answer. All right. Now this one is a little bit difficult, maybe. Okay. Okay, so same method around the trip between city A and the city B, which are 100 miles apart from each other. The average speed from city A to city B is 50 miles per hour. And the average speed from city B to city A is 60 miles per hour. What is Sam's average speed? Yeah, this is a little bit tricky problem. Right. Little bit tricky problem. Okay. Right. And most of people post the answer to the co-host, which is awesome. All right. Michael, you may have to redo the problem. Right. So you have A to B and go back from B to A, right? So you already know the speed from A to B, 50 miles per hour. Here's a 6 miles per hour, okay? Right? So recall, you have to recall the definition. Yeah, Michael Lee, okay? I see your answer, which is not correct. Yeah, please redo it. All right, so you have to use the original definition of the speed, okay? The average speed is not going to be the average value of two speeds. That's my warning. Anyone has answer now? Nobody? Yeah, if you have answers, don't be shy. You just post to me privately, so I can. Yeah, you don't need to show to everybody. Okay. All right. So let's see how do we do this problem. So according to the formula, the definition, right? The distance divided by time. So you have to figure out the distance and the time, right? So the time is not given, but the distance is given. The total distance is going to be 100 plus 100 equals 200. So you put the miles here, okay? The time is going to be, you have to do the calculation time. So first of all, it's 100 miles divided by 50. That's the time from travels from city A to city B. And the second one is 100 divided by 60 miles per hour. Okay, so we have to simplify a little bit. The first one is 2, right? The second one is going to be not 2, right? 10 over 6, it's a 5 over 3, okay? So let's use a fraction, okay? Right? 10 over 6 is, 5 over 3, okay? And this is going to be 11, okay? This is 11 hour divided by 3, okay? So using that, you can get a speed. Speed is going to be, right? Speed is going to be 200 divided by 11 over 3. And it's 200 times 3 divided by 11. Right? Divided by 11. So it's going to be 600 divided by 11. So miles per hour. Now you can also run it to, right? If you use a calculator, you can run it to some numbers, right? 600 divided by 11, it's about 54.54 miles per hour. Okay. Okay, so that's it. I think Michael did a good job. Right. Got it? Yeah, it's not going to be average value of the two speeds. You have to use the original definition of the speed. Okay, so this whole trip is a round trip. It travels 200 miles. Okay, and how many hours? 11 over 3 hours. Then you do the division. Okay, then you solve the problem. All right. So let's see. We try to set up set up a formula in general. Okay, so distance from village A to village X to village Y is d miles. Okay, so from X to Y is d miles. Okay. Then we walked from village X to village V at a constant speed of v miles per hour. Okay. When he was walking on the way, he took a rest for t minutes. What is the average speed? Okay, can you express it in the formula without doing computation here? Okay, so do you understand that, right? When he walks, it's at a constant speed, but he also took a rest for t minutes, right? So otherwise, so you don't need to do any computations. The average, the average speed is just v miles per hour, right? It's already given. Right. All right, so I don't know where looking, sorry, right? So let's see. So the distance it travels, it's already given, it's d miles. The question is how much time it takes for him to complete this travel, right? So the time, assuming he does not stop, right? The time he travels d divided by v, right? The time t, okay? So d divided by v is the time he's going to spend on the road without the stop, right? But now he took a rest, right? He took a rest. So that's why he had to add t minutes. That's a total time he spent, okay, eventually, right? Think about that, right? If without stopping, right, that's a v divided by d, that's the whole time he spent. Now he stopped somewhere for t minutes, okay? But t minutes have to convert it to, be careful, t minutes have to convert it to hours divided by 6, right? So that's a total, that's in hours. Be careful about the hours, right? Yeah, then the speed, average speed is the distance divided by v. Okay, so you get the expression, okay? Yeah. If he did not stop somewhere, he keep walking. That's how much time he can spend, d divided by v. But he stopped. So he take extra 2 minutes to complete this trip. That's all you needed to know. Okay? To take extra time to complete this trip, yeah. Right? So that's all we needed to know. All right, so now let's take a look at the second problem, the sixth problem. So Alex leaves his house at 7 a.m. and bikes at a constant speed, 6 miles per hour to east. Okay, so here's going to this way, east. Okay, this is right-hand side east, okay? And John lives 100 miles per hour. Okay, this is Alex. That's John. Okay, draw the picture, okay? 100 miles per hour, 100 miles. Okay. On the east side of Alex, right? So he leaves his house at 8 o'clock a.m., bikes at a constant speed, okay? Constant speed of 10 miles per hour to west. At what time do they meet? At what time? Okay, so when they meet somewhere here, okay, So you have to, the total distance they travel is 100 miles because otherwise they're not going to meet. That's a short, right? So that's my hint. Anyone can quickly solve the problem? Right, at what time? So you can say that you have to name the variable t hours after 8 a.m., right? Yeah, their meet, right, in t hours after 8 minutes. So we can say that, then you add it, right? Their meet in t hours after 8 a.m. How about like that? So you have to name the variable, right? Then you try to set up equation to equation in t, so you can solve the problem, right? So t hours after 8 a.m. So you're going to get a linear equation. Now, how many miles Alex travels? Alex start, right? Alex left home at 7 a.m. So t hours after 8 a.m. So he already spent 1 plus t hours at the constant speed. So for Alex, right, 16 times t plus 1, right? That is the distance he travels, right? Time, speed, and time. Then for John, right? His speed is 10 miles per hour, t times t. That's the total distance he traveled. They meet, so they should total travel 100 miles. So that is the equation you're going to get. Okay, that is good. So you name the variable first. Okay, then usually for the quantity in the question. Okay, then you write down, use something to write down the equation. Here we use a distance. They meet somewhere. So that means they're going, the total distance they travel, add up should be 100 miles. Then you solve the equation. This is a linear equation, right? How do you solve the equation? Right, we multiply, 16t plus 16, 10t equals 100, right? Multiply them out. 16 plus 10 is going to be 26t, and here's 100 minus 16. Okay, it's going to be 84, right? Then t is going to be 84 divided by 26. I hope we can, I'm not sure it's good. Integer 84 divided by 26. It's not an integer, okay? So we just simplified a little bit, right? So 84 divided by 2. So it's going to be 42, and here's a 13, okay? And then anyway, this is in hours. So you just needed to add it to 8 minutes, right? Let's convert it to the minutes, okay? So this is a good question. 42 divided by 13, okay, 3 hours, right? 3 hours and 22, it's about 3.23 hours, okay? Now 0.23 times 60 will be about 14 minutes, okay? Okay, so it's going to be about 3 hours, 14 minutes. Okay, so you add it to 8 o'clock, right? 8 plus 3 hours, right? It's going to be 11 and 40. So that's about, 11, 40, 14. Okay, so that means not exactly. Okay, so you have to find the time, how much time after 8 o'clock a.m. So this is a problem. The first problem, we have to set up equation to solve it. Okay, we already learned linear equations, right? How to solve linear equations in the previous lectures. So for the solving problem like that, if you cannot solve the problem in one step, just like what we did in the multiplication, then more likely you're going to name the variables, set the equations, then try to simplify the equation and solve it. Okay. This is called the word problem, typical word problem. All right. Yeah, here 2 dogs run around a circular track 300 feet long in the same direction. One dog runs at a steady rate of 16 feet per second, and the other at a steady rate of 12 feet per second. So suppose, no, it should be, come on, it's not, is that fast? Okay, let's assume, okay. So suppose that they start at the same point at the same time, it's going to be like that. Okay. Draw the picture, right? Now, what is the least number of seconds that will elapse before they meet again? So one runs fast, the other one runs slow. The faster one will eventually, it's the faster one here, the second here, eventually will catch the second one, right? The slow one. Okay, when the slow one, this is dog A, that's the dog B, and then dog A is here, dog B is here, you know that. Then finally, the dog A can catch up to dog B, right? So the key point is the distance, not the direct distance, the distance between this distance we're talking about, not the, yeah. So this distance is getting, at the very beginning, is going to be 300 feet, right? But it's getting shorter and shorter, then they meet. The first dog will catch the second dog, right? That's my hint. Can you do this? When right, you have, when at the very beginning, the distance between these 2 dogs actually is 300 feet. Yeah, although they're starting at the same point, okay, just a little bit, you know, away from the starting point. The distance between those 2 dogs actually is going to be 300 feet. Then that gap is getting smaller and smaller. Eventually, the faster dog catch the second dog on the back side. Okay. So the difference of that speed, okay, the difference of that speed is going to be, yeah, the difference of their speeds is going to be 16 minus 12, 4 feet per second. Okay, 4 feet per second. Okay, so that means the distance between A and B around that other side, okay, is decreased by 4 feet per second. Okay, 4 feet per second. The distance from A to B, okay, not from B to A, from A to B is going to be decreased by, yeah, decreased by 4 feet per second. Is decreasing at a rate of 4 feet per second. So the answer is the time is going to be times the distance 300 divided by 4. Okay, that is the answer. Okay, total distance, divided by 4, right? It's going to be 75 seconds. Okay, 75 seconds. Yeah. Okay, so think about, this is not the direct distance. Okay, the distance from A to B is, right? It's from, on the back side of the B. Okay, that is the distance getting short and short, short. So it's decreasing at the rate of 4 feet per second. So see, solving this kind of problem at the very beginning was confusing because they both are moving, right? But you have to do some analysis and figure out the key point, right? And how to make sure they are getting, the fast dog can catch the slow dog, right? Because there's the distance from A to B. At the very beginning is 300 feet and beginning small. Okay. All right. So the next one, you still have to draw the picture. Okay. A train traveling at 30 miles per hour. It's very slow. Okay. Reaches the tunnel that is 9 times longer than the train. Okay. If the train takes 2 minutes to completely clean the tunnel, and then how long is the train in the feet? Okay, so this is a tunnel. Okay, here's a train. Okay, you draw the picture, then going through, right? Okay. So we so to clean it, right? The train will be here, right? So that means the train will travel this many distance from here to here. That is the distance the train has to travel. Okay. The question is, the question is, you have to figure out the distance it travels in 2 minutes. Okay, you already know the speed, right? Per hour, right? So speed is per hour. So the distance it travels, that's called d, right? Draw the pictures and it's clear. What is the distance the train must travel? Okay, the distance it travel is going to be the speed. Okay, that is speed times time, right? So speed times time, and that is going to be 30 miles, okay? 30 miles, time in, right? 30 miles, right? 2 minutes, right? 2 minutes, 2 divided by 60. 2 divided by 60, so that's in hour, okay? So that means it only has one, right? 1 mile. The 1 mile is going to be 5,280 feet. Okay, so that's the distance. Then you know that the tunnel's length is 9 times the train. So total D is going to be 10 times the length of the train. So this is 10 times the length of the train. Right? So the length of the train is going to be, right? Divided by 10. Okay, so that's it. I think the picture is important when you solve the story problem. So you draw the picture first, then you can figure it out, and you write the formula you have to use. The distance is equal to speed of times. The distance, speed of time. Okay, then you figure out the distance the train will travel in 2 minutes. Then you figure out the length of the track. Okay. All right, now we're talking about other rates. Okay. A host fills a swimming pool at the rate of 10 gallons per minute. If the pool's capacity is 10,000 gallons, and then how many hours does it take for the host to completely fill the empty pool? Okay, this is just a direct computation, but it's not a. We still can talk about the speed here, right? And I think you have to convert it to how long, how many hours, right? So you have to, what you get is, the time, right? The time should be equal to, and this time it's not a speed, it's a volume actually. Volume times the rate, okay? So the rate is going to be the volume divided by time. So here we don't use a distance, we use a volume, okay? And then the ratio is called the rate, or you still can call the speed. So that's a formula, okay? And then from here, you can get the time, right? So volume is going to be 10,000 gallons, okay? And the rate is 10 gallons per minute. So what you get is going to be 1,000 minutes, okay? Now, if you have to find out the time in hours, then you have to convert it in hours, right? So it's going to be 1,000 divided by 60. Okay, after you simplify, or you can simplify it further. Okay, so this is going to be divided by 2 at the 50 over 3. Okay, so that's it. Yeah, you can run it. I like this answer. That's it. You don't need to use the decimal forms to compute. Okay, so that's the. Okay, this is about other rates. So we don't have a specific name for each of the problems. So we just call it the rate. Okay, and here use a volume. Sometimes use the area. Sometimes I don't know, any kind of units could be. Okay, so it depends on the problem. Okay, for example, here. Okay, Brian wants to give a 1 hour speech. Okay. Ryan wants to give a 1 hour speech. He speaks about 120 words per minute. His written notes contains 360 words per page. How many pages should he prepare? Okay. So this one, right? It's a 1 hour speech. Okay, so you just needed to know, and the rate is given, right? 120 words per minute. So the rate is given 120 words per minute. Okay, that is the rate, right? So if it's 1 hour, then how many words you're going to get, right? We can use a notation, W, this is the number of the words, right? So the number of the words, it's called, so rate equals, W means number of the words, and here's the time, right? That's our formula. So the number of the words is going to be rate times time, okay? Right, rate times time. So this will be, will be 120 words, and the 1 hour is 60 minutes, right? So you multiply this out, okay? You multiply this out, and then you can get, 7, this many words, okay? So now, one page is 360 words. So that's why number of the pages is going to be divided by, you have to do another division, right? So it's another rate, right? So that's going to be 20 pages. Okay. So let's take a look at this problem. Okay. Mr. Wang's car tires that have a circumference 80 inches. So this is a circle. 80 inches. Okay, the circle is going around, rotating around, right? So if it's a point here, and then when we're going this way, right? Maybe this point here in a few minutes later. Okay, it's rotate. Right. How many revolutions will his tires make if missed one drivers to a store that is about 2 miles away? That's just division problem, right? So the distance, okay, one revolution, right, is equal to the circumference 80 inches. So one revolution, right, is going to be 80 inches. Right? One revolution, it travel 80 inches. So we're talking about, we're trying to find how many revolutions. Okay. So that means all you have to do is the distance divided by the total distance divided by the distance it travels for one revolution. Okay, so how many is the number of the revolutions? Okay, it's the total distance, 2 miles times 5,280, that's a feet, and you convert it to inches, 1 feet equals 12 inches, and divide by 80. Okay, right? Just saw how many 80s there, right? Right, 180 inches, right? It's going to be, one revolution, it travels 80 inches. So it's 2 times 12 times 5,280, right? Divided by 80 is going to be 1,584. Right. So that's the total number of rotations. Yes, revolutions. All right. So now we're going to look at another type of problem. I'll let you to try first. I'm not going to work on this. Okay. I'll give you 1 minute. We have enough time to do that. And so if you have answers, please post it to me privately. So David can paint a wall of 100 square feet in 2 hours, while John can paint a wall of 200 square feet in 3 hours. So if they work together, then how long will it take them to paint 7 walls of 100? Yeah, each has area of 100 square feet. So on the record, I know the speed, okay? So David can paint a wall of 100 square feet in 2 hours. It looks like John can paint faster, 3 hours paint 200 square feet, right? If they work together. If they work together, how long will it take, okay? So I think all you need to know is the total area divided by the combined rate, combined speed. Okay, that's my hint, combined speed. Because they work together, right? If David can paint 10 square feet per hour, for example, John can paint 15 square feet per hour, then if they work together, 1 hour they can paint, 10 plus 15, right? 25 square feet. So it's called a combined speed. Right? Okay, a couple of students show me the answers now. Okay, let's do this problem. Okay, so you have to figure out the combined speed. Okay, and the rate, the Davis rate. Okay, it's called R1, is going to be 100 square feet divided by 2 hours, right? You don't need to simplify right now. R2, John's speed is 200 divided by 3 hours. Okay. So the combined rate is going to be add them together. Okay. That's it, right? Now you can simplify a little bit. Okay, what I'm going to do is I combine them, right? So it's going to be 6 here. 3 plus 4 is a 7. 700. Okay, you can do this computation. Okay, 700 divided by 6. That is a square feet per hour. Okay. So now the total area, right? Total area is going to be a 7 wall. Each of them 700. Okay, square feet. So the time is going to be the area divided by the rate. So it's going to be, right? It's going to be 700 divided by 6 and divided by 7. Hold on. It's opposite, yeah. Right? So 700 divided by 700 divided by 6 over 6. Okay, and then after simplifying, it's a 6 hour. Okay, so the formula here we are using the rate is going to be the area divided by time. You know, time is going to be the area divided by the rate. Okay, you can write down those formulas here, and when you solve the problem. Okay, right? Yes. All right. So the next one. At a certain firm, 24 gallons of fuel are needed per day for each truck. At this rate, 1,560 gallons of fuel will supply 5 trucks for how many days? Okay, for how many days? I give you 1 minute. Okay, so first of all, you have to figure it out. Okay, for 5 trucks, how many gasoline of the fuels are needed per day, right? Yeah. So this is for 5 trucks together. Okay. For 5 trucks. Okay. Right. For 5 trucks, we need. We need 24 times 5 these gallons per day. That's a new rate, right? The rate can, yeah, that's only 2 units per gallon per day. Okay, so this is a total. Then, right, you have a 1,560 gallons of fuel. Just all I have to do is just division. Okay, the time is going to be the total amount of gallons divided by 24 times 5. Okay, then just do the computation, right? 1,560 divided by 24 and divided by 5. So it's going to be 13. Yeah, 13 days. Okay, 13 days is correct. Good job. Okay. So that's no equation you need. Just make sure you find the rate. The rate in many different forms. Here, this 24 gallons per day per truck is one rate. And for 5 trucks, it's also another type of rate. Okay, 24 times 5, okay, gallons per day. This is the rate for 5 trucks. You can find them together. Okay, then this new rate, the total volume is 1,560 divided by the rate, then give the time. Okay, so finally, let's take a look at the next problem. Yeah. Okay, a tank with capacity of 3,000 gallons is empty. If water flows into the tank from pipe X at the rate of 25 gallons per minute, and what is pumped out by pump Y at the rate of 20 gallons per minute, in how many hours will the tank be filled? Okay, you have a big tank here. Okay, so when it's in, that's X, right? When it's out, that's by the pump Y. Okay, so the combined rate, this time, you have to use a difference, right? 25 minus 20, so every minute you get 5 gallons per minute. Okay, you get 5 gallons per minute. Do you agree? Yeah. So the rate, so that's why, then how many hours? The time is going to be the volume divided by the rate. It's a 3,000 divided by 5 and 600 hours, 600 minutes. Okay, and that's going to be 10 hours. Okay. All right. So at the end, I'm going to ask you to do this problem, tricky problem. So that's your house. That's a school. Okay, that's a school. Okay, here's a home. That's a school. Okay. So in the morning, you forgot. After you get home, you forgot something. So you run to the school. It's 4 miles per hour. Okay, you get the book and you run back, or you walk back. It's slowed down. It's 2 miles per hour. Can we find the average speed for this round trip? What is the average speed for this round trip? Okay. This problem is slightly different from the previous problem because we don't know the distance between your home and the school, because some people live nearby and you don't have a school bus yet. Okay, so you rent to school to get a book and come back. But when you come back, you relax, you just walk slowly, But at the beginning, you rent. The very common mistakes is that students will give the average value of this two speed, like 3 miles per hour, which is wrong. Okay, what you have to do is you have to measure the distance. You don't know the d. Okay, you can say d miles, you can say 5 miles, 10 miles, doesn't matter. Okay, so the total distance with d plus d around the trip is 2d. Okay, and you will see this d will be gone. The time is the time from home to the school will be d divided by 4. And from school to the home will be divided by 2. Okay, add them together, this will be a quarter plus, I think it's 3/4d. Okay, that is a time. You see, then the average speed is the distance divided by time, and that is going to be 2d and 3/4d. And then you find out the distance between your home and the school. You don't need to know. Okay, all you have to know is going to be 2 times 4/3, which is going to be 8/3. Okay, 8/3 is about, it's bigger than 2. 8 divided by 3, it's about 2.66 miles per hour. Okay, so that is the answer. Okay, so this is a very typical problem, pretty tricky problem. And sometimes you're confused because you're not given, not like this problem I discussed before, similar problem, but I given you the distance. But here the distance is not given, but you name the variable. You can call, you can say about 1 miles between your home and the school, but doesn't matter. So you will see that this D canceled out. Okay, so you're given enough information to figure it out. The common mistakes is just find the average value of two speeds. That's not the formula we use to find average speed. Average speed must be the total distance it travels and divided by time. Okay, got it? Yeah, so we're done with today's class. And I hope, you will get the homework assignment. And I hope you will continue study.